Alright, so here we go. Once again. Going live. Okay. Hello. Hello. So what we're going to do is we're going to figure out how to read this abacus. And this is what we're doing. This is what we're doing. So we are looking at the abacus. The top B is a value of 5. The bottom B is a value of 1. And so when we're looking, we are, anytime the beads are counted, the beads are counted whenever the beads are touching this horizontal line. So we have our 0 here because it's not colored. So this is colored. So this is actually 8. This is 80. And then this is 70. No, this is 7. So it's 780. Maybe I don't like this one. Maybe I'll just go back to this one. All right. So let's try this one. Okay. Hello, everybody. Hello. Hello. Sorry. So let's try this again. So we have our number. Let's see. There we go. So we have our number. All right. How are you doing? So we have 1,000. No. We have our hundreds, our tens, and our ones. We have our hundreds, which is 6. 5 plus 1 is 6. We have 5 plus 8. 5 plus 8. I'm sorry, 5 plus 3 is 8, and then 5 plus 2 is 7. So we have 687. So when we're looking, we have our hundreds. This is our hundreds, our tens, and our ones. How are we doing? All right. So thank you everybody for joining. Thank you everybody for joining. What we're doing is we're learning how to read the abacus. We have 687. That's what 687 looks like. 687. And then we have our next number. Thank you so much for liking the live. So we have our hundreds, we have our tens, and then we have our ones. Notice all the bottom beads are touching this horizontal bar. Because the bottom bead's touching the horizontal bar, this is what's being counted. The top bead's not being counted, so it's not touching the horizontal bar. So this is actually 4 because it's all 4. 1, 1, 1, 1. This is 4. This is 2, 1, 1, and then this is 1. So this is 421. Thank you so much for liking the live. Thank you, everybody. Welcome, welcome, welcome. So we have 421. And it'll take us to our next number. We have this one right here. We have our next number. So notice that we have the hundreds, we have the tens, and we have the ones. That's what that would look like. So we have our hundreds, tens, and our ones. Welcome, everybody. Welcome, welcome. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
So when we're looking, right, we have our hundreds. This is 1. This is 9. How do I get 9? Well, 9 is because we have the top bead is touching the horizontal bar, and then we have 4 bottom beads. 1, 1, 1, 1. These are all touching the horizontal bar, so this becomes 9, and then this becomes 4. So we have 1, 2, 3, 4, 4. There's 4 here. So this is 194. Welcome, everybody. Welcome. Thank you so much for checking in, for joining. For those of you that are interested, please. Oh, I see. Maybe I should do by seconds. Done. Try that. Okay. There we go. There we go. So, hello everybody. Hello. Thank you so much for joining. What we're doing is we're reading 194. That's what we're doing. Thank you so much for the share, Jocelyn. Thank you so much for the share. Can you explain the blue ones? The blue ones? The blue ones is a value of 5, right? So if we're going to look, that's all it is. If I have this number, if I had this number, it'd be 3,456. Thank you, content. And so when we're looking, right, we have our place values. We have our ones, our tens, our hundreds, and our thousands. Hello, Tax! I'm still doing abacus. That's all I do. I've been doing abacus for 20 years. So we have our next number, right? We have our 73,456 point. There's a decimal right here, tenths, and then the hundredths. So we have the 2 and the 5. So we have 73,456.25. Have a great night. Thank you so much, Tax. Thank you so much, Tax. Have a good night. Have a good night.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
All right. So then if I did this, Content, you still around?
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So we have 55,000, right? This is the 10,000s, the thousands. We have 500 because we're at the hundreds. We have the tens and the ones. Point 10 55. So we have 55,555.55. Thank you, Tim Tool, for the tiny tiny. Thank you so much. Did that work? That's not working. Thank you so much. Thank you so much. How do you know that's fives? Because I've been teaching Abacus for 20 years. That's how I know it's fives. These are all fives. That's all it is. These are fives. So when we're looking, right, we have 1, 2, 3, 4. I'm asking because I don't know. Well, you're asking me, how do I know? How do I know is because I've been teaching it. You should be asking, maybe you should be asking is like, is the blue 5? What do you use it for? You can use it for arithmetic. So you could use it for adding, subtracting, multiplying, and dividing. You can use it for counting sheep. You can use it for keeping track. You can use it for keeping your brain active, like Sudoku. So it'd be comparable of doing arithmetic, like, doing Sudoku, crossword puzzles, jigsaw puzzles, word searches, and, strategic things like puzzles, anything that has to do with a puzzle, because Abacus is like a puzzle. So that's what I would use it for. If you have young children, it would be good to introduce Abacus to young children to get them to have stronger number sense. And when we're looking, if you're older, it would be a nice hobby to learn something new. So, how to what? Oh, hey, DJ. Hello, welcome back, LD. Yeah, yeah, you're right, Ghost. That is chemistry. I'm not here for chemistry. I'm here for arithmetic. Nah. For finances. Oh, content. Can you show you doing some addition? My grandpa used it for his finances. What kind of abacus did he use? Was it two beads on top, or was it two beads on top or one bead on top? I'm here with oh, that's great. Oh, that's great. Okay, I'm sorry. I'm reading all the comments. So we could do multiplication. Hello, Mr. Skittle. Basic arithmetic for adults. Oh, really? You're on page 27? Let's see. My hand won't have one in our office. Yeah, I've always wondered how it works. Oh, yeah, that's how it works. 27. So this, for those of you that are interested, I did create a abacus for adults, and LD is on page 27. Oh yeah, oh yeah, this is a good one because we're talking about how to make a 5. Oh yeah, I actually blew my friend away. His mind was so blown when I told him how to do adding and subtracting on the abacus. He was like crazy. Okay, remembering, it might be 2. Okay. So, if it was a 2 bead, it would look like this, right? So if it was 2 bead, it would look like this. This is a Chinese abacus. The Chinese abacus, it works very similar. So we had 1, 2, 3, 4, 5, right? We have 1, 2, 3, 4. Notice that this is 5. We're going to trade this in to the top. So that's what that would be. So then because this is 5, then we do 6, 7, 8, 9, 10. And then because we have this, you're going to trade this in to be like that. So this is 10, so you trade it in to be like that. There you go. So, oh yeah, Tim, that's cool. 2 beads on top. Yep. So then, if that's the case, then what she did was she did the Chinese abacus, which is very different than, it's a little bit different than the abacus, the Japanese abacus. So, this is like, I need it for school 125. Yeah. So what we're doing is we're visualizing our numbers. We have 4, right? This is 4, and then we have 5. We have 6, 7, 8, 9, and then 10. That's what 10 would look like. So when you're looking, we have this dot. This dot tells me that this is the ones place. That's what this is. Let's see if I can do that. There we go. So this is the dot. This is tells me the ones place. Because this is the ones place, right? And then you'll notice there's another dot here. Well, now I can actually choose this one. Here we have ones and then thousands. That's what that would be. Make sense? So you can actually choose any of these dots. These are just labels. You could choose any of these labels to be your ones place. We're Chinese, so that makes sense. Page 22. Oh yeah, okay. Yeah. So looking at it, yeah, that's good. So you're just starting to wait. Oh, when you look at the pixel art, oh, you can't see the pixel art. When you do the pixel art, LD, when you do the pixel art, make sure you do it on the abacus because the idea is to see the numbers, right? To see the beads. So if I have 7 on the abacus, like that, 7 on the, I want to take away 2. I want to take away the 2. So you take away the 2 like that. Thank you so much for the rose. Thank you so much. Thank you, Tim, for the finger heart and the tiny diny. Yeah. So when we're looking, you want to make sure you you move the beads. The questions are super easy, but it's meant for you to move the beads. You're just gonna have to kind of go through the motions to get your brain practicing what it would look like on the abacus. So it makes sense to use the rather than write it in your head. It helps to track your numbers on the abacus. That's what it will do. It's interesting that once you're able to see the numbers, it's really amazing that you can actually figure out how to add, subtract, multiply, and divide. Let's see. How is this? Okay, there we go. There we go. Yeah. Yes, finger motions and counting too. Yeah. So you could use your fingers. That's fine too. There's no judgment, but it is what it is. I'm not here to convince you otherwise. I'm just here to show you how to read an abacus, and I'm showing you how to use it. It is up to you if you want to use it as a tool for what it is. If you don't, there's no harm, no foul. All right. So if you would rather use your fingers, then that's fine. Use your fingers. Yeah, the thumb and the pointer. Yep. And so when I would do it, that would be 94. Oh, so we have our next number. I don't know why people need to tell me these things. Like, why don't you just use a calculator? It's like, that's fine. You could use a calculator. I'm not here to judge. And then that's what it is, right? It's like, I use a car. I can also walk. You can use a calculator. I also use the abacus. That's all. So, thank you, LD, right? Try it all. Just try it. If you don't like it, then don't use it. If you like it, then great. But I'm not here to say this is the only way. Yeah, everybody has their own preference. Yeah. Oh, thank you, LD. Yes, I like it too. So we have our number. Give them the tools and make. Yeah, I'm giving you the information. It is completely up to you if you want to use it or not. I'm not here to judge. So our next number, we have 717. So we have our top beat is a value of 5, and the bottom beat is a value of 1. So 5 plus 2 is equal to 7. So that whenever the beads are touching the horizontal bar, they're being counted. So we have 5 plus 2 is equal to 7. We have 1, and then we have it again. 5 plus 2 is equal to 7. Notice that the top beat is not touching the horizontal bar, so this is not being counted. When we're looking, this is 1. We can do 2 and then 3. But if I add the 5, like this becomes 8 because it's 5 plus 3 is equal to 8. And then we have that. So our final answer is 717. We have our next number. Let's try this one. So it's a 3-digit number. Why is it 3? Because there's 3 columns. Each column has a number, and each number is represented on the abacus. So we could do this number. This is our ones, our tens, and our hundreds. So when we're looking, we have our ones, our tens, and our hundreds. Oh, I can't see that. So what number do you think this is? Notice that the top beat is not touching the horizontal bar, so they're not being counted. So this would be 2 200 because we have our ones, our tens, and our hundreds. This is 232. Thank you, Anarchy. Thank you so much. And so we have our number. We have 232. And so we have our next number. Huh. I wonder. That's not working. Oh, I wonder. Okay, so we have our next number. Thank you. Okay, I'm sorry. I have one question about the book formula. How do I fill it out? Okay, hold on. So I think I'm getting it. I love, Dino. Yeah, 21. Oh, okay. So 21, my grandmother had the wooden one, as long as I can remember. I don't think she ever used it. Not 21. Not 21, because this is just showing you how to move the abacus. It's not 21. Oh, not a problem, Anarchy. Not a problem. This is just showing you the abacus. So for those of you that are interested, this is available in my TikTok shop. I actually created a book for adults. So, hello, Plant Lady. Thank you so much for the share. Thank you so much for the share. So when we're looking, it's just showing you the beads. That's all it's doing. So we have the one thumb up means that you just do the one thumb up. That's all it is. That's not the, thank you so much for the tiny diny, Tim. LD? Oh, dry erase, sorry. So, I have too many books. Okay, 21. Okay, so, 21. Here we go. Okay, so we're talking about the 5 plus 5, right? Okay. What we're going to do is we need to isolate the variable. To isolate the variable, we need to minus the 5. So when we minus the 5, thank you, Plant Lady. So minus the 5 is what? Minus the 5 is equal to minus the 10, because we keep that as a minus. And then what happens? This 5 goes to this side over here. So this becomes plus the 5. That's it. And so then when you rewrite it, right, this right here, rewrite the cumulative property means what? Minus the 5 is equal to minus the 10 plus the 5, and then you have to flip it. Minus the 5 is equal to plus the 5 minus 10. And that's it. So then when I give you the question over here, it's to show you how to add the 5. We have the 10. I'm sorry, take away the 5. We have the 10. We have to minus the 5. We substitute minus the 10 plus the 5. So my final answer is 5. That's why. Yep, that's how you do it. So then, that's how you do it. So it's the same thing with the others. It's exactly the same as all the others. Because what I'm doing is I'm compounding the information, right? So we could do it again with here. We have minus 6 equals, minus 4 minus 6 equals minus 10. Same thing. We're trying to subtract this 4. So we're going to minus the 4 is equal to what? Minus the 10, right? This is the constant. And then we want to plus the 6. Does that make sense, LD? So we can do it again, right? We could do it again. We have to minus the 4 is equal to minus the 10 plus the 6, or it's minus the 4 is equal to plus the 6 minus the 10. Having a little bit of trouble with this one, definitely worth learning. The trouble of the formula. The formula is a minus 10. And so when we're looking, just as how you add, you will subtract. So this is all about the minus 10s. So the back of the book is the minus. The front is the plus. So anything of the even is the plus. Yeah, writing it. Yeah, it does take time and it does take practice. Sometimes what I would do, is I would chant it out. So I would say minus the 5 is equal to minus the 10 plus the 5. I would keep saying that. Plus the minus the 5 is equal to plus the 5 minus the 10. And you keep saying it until your brain can hear it. That's what I would do. And I tell the kids to do it too, because it's one of those things, like, it's just once you say it enough times, your brain will start wrapping your head around it. You know what I mean? Because you're also not keeping it in your head. Yeah, I would focus in on saying it out loud as well. Thank you, Rico, for the follow. Thank you so much. Is that working? That's not working. All right, so, okay, we're gonna continue on with reading the abacus. So that was a little bit about formulas, and again, oh, thank you, LD, for the roses. Thank you so much for the roses. So you'll notice that the way the book is, there's the adding is the front side, and it's the same, right? Plus the 4 is equal to plus the 10 minus the 6, and then you do the opposite, right? It would be plus 4 is equal to minus the 6 plus the 10, right? Or plus the 4 is equal to plus the 10 minus 6. Could you do a little more formulas next time? I'm having a hard time with them. Oh, you want to do more formulas? Okay, we could. Um, we could do, well, okay. So I'm assuming that everybody understands how to read the abacus, because that's the biggest thing, is making sure that everybody understands how to read the abacus. Once they know how to read the abacus, then doing the formulas is actually pretty good. Yeah, not a problem. No, thank you. Thank you, LD, for coming by and letting me know. Yeah, not a problem. Not a problem. I do appreciate all these conversations, because that's the one thing, is trying to move the whole class up. Trying to move the whole class up. Hello, Shadow. Hello, Shadow. Hello, NZ. Yes, saying it out loud helps. Yes, saying it out loud really helps. And then, even to this day, I still say it out loud, but I don't write it out. When I say it out loud, I can hear myself. So I don't write it out. The only reason why I write it out is to show you guys. But for the most part, saying it out loud helps me. All right, so we will continue on with plus fives. We'll do fives, plus fives. So are we done with this? Do we know how to read the abacus? Let's do a little more. Let's do a little more. So we have this. We have our hundreds, our tens, and our ones. What number do we have? I wonder. I wonder if I have to... There we go. Thank you. Yes, thank you. 341. Okay, good. Don't worry. I'm licensed. I carry my... Hello, Burly Boy. Thank you, Bean Boy. Okay, so we kind of know what it is, right? Thank you, Burly Boy, for checking in. Thank you so much. For those of you that are interested, there is an orange heart above my head. You can go ahead and you can check in to be a part of my community. Thank you, Dave, for the tiny diny. Thank you so much for the tiny diny. I do appreciate it. I do appreciate it. And so I think we're done. There was a few people that were like kind of new, and then we started going into something else. Anarchy, did that make sense? I have the wooden model for hers as long as I remember. I don't think she knows how to use it. Yeah. Tim Tool, did that make sense? All right, Tim Tool. I don't know if Tim Tool is still here. Okay, we're gonna continue on of how to move the beats. No, we're gonna continue on how to. Yeah, we'll continue on how to move the beats. So you might be wondering, what are you wondering? What are you wondering? You're wondering how to move the beats. Are you aware you're carrying... This is my other book. This book was meant for children. This book was for children that are 3, 4, and 5. Just because I wanted to get them young. If they know how to start, if they already started counting, then I would start introducing the abacus, just because it would help them. One, helps them to visualize their numbers, and two, it's something concrete, right? Just like when they count on their fingers, they count on their toes, they count, how many cars they have, or they count how many they count how many dolls they have, right? What they're doing is they're just understanding the correlation of counting and understanding the quantity. So I'm not saying to, like, you have to show them at this age. It's just, if they're already showing interest in counting, I would introduce the abacus. That's what I would do. So here is my abacus preschool preschool abacus for preschool abacus. And so I give you an information like how to read the beads, and all it is just understanding the numbers and how they correlate to the abacus and the actual numbers themselves. When we have 1, we have 2, we go all the way to 4 right now, and then we have all these activities. And again, I give you pixel art, and then we go into 5. 5 to 9, you're smuggling a foreign abacus is wrong night. I wonder if they're going to turn off TikTok. What do you think? Because it's supposed to be like the deadline tomorrow. So then I was like, I wonder. It would really suck. So then we're just doing 5 to 9. And then after 5 to 9, we start counting. And we start counting. And we have these activities, and then we start counting forward. After counting forward, we count backwards. After counting backwards, we figure out what comes in between. So what we're doing is we're understanding the concepts of the numbers and the relationship, and then we start talking about their surrounding, and then we have the bigger than and less than comparison, and then we start going into adding and subtracting. Okay, so here was a thing that just kind of made a new pathway for one of my friends. On the Abacus World, if they do, where would you watch on? I would be on YouTube. Yeah, that would be my thing. I mean, I have a channel and stuff, and I tried to. Yeah, I would be on YouTube. I would try my. Yeah, I would just be doing it on YouTube, but it won't be as long as this one, because what keeps me on here is because everybody keeps asking questions, and the algorithm on TikTok is really good. So yeah, I'd be on YouTube. Yeah, I do have a thing there. I don't like Facebook so much, but I do like YouTube, because Facebook doesn't announce my when I go live, but I know that if you subscribe to me, you get the notifications that I go live. Yeah, I read the deadlines are being extended. Yeah, I read that too. And then there's going to be a whole talk on Friday, and then there's all this. I was like, okay, well, it is what it is. It would suck, but it is what it is. And I'm sure something else will come up, but we'll see. So, YouTube does have a chat. Yeah, YouTube does have a chat. I think the one problem with YouTube is that it doesn't push out like TikTok. So my subscribers will get the notification, but if you don't subscribe to me, then you don't know. And then I think I'd be more right. I don't know if I'd be more regular. It's hard to be scheduled. I would like to be more on a consistent time basis, but with the way the family is, it's kind of difficult. So, so here we are. We're going to be learning how to move the beads. The reason why is because we just want to know how the beads move. So I have 7 on the abacus, right? This is 7. 5 plus 2 is equal to 7. I want to add the 1. Now, the one thing about mainstream math is that they're always focusing on the result, or they focus on the first number. They never focus on the second number. The second number is what's going to tell you whether or not you're going to need a formula or not. So, hey, you want to use an abacus? All the cool kids are Burley. That's funny. So we want to add the 1. We want to add the 1. And so my final answer is 8. So what we're doing is we're understanding the second number. It's the second number that's going to tell us and dictate whether or not we're going to be using a formula. What happens when there's not enough? So we can keep going, right? And so this one is 5 plus 3. We have 5 on the abacus. We want to add the 3. Notice that you could do the dots like mainstream math, or you could do the tally. But in abacus world, we just need to use the abacus. We have 5 plus 3. But now what we can do is we can actually supertize. We know that this is 8 because we could see that this is 5 plus 3 is equal to 8. However, it's hard to supertize here. Supertizing means that if you look at the number, you know what it is. On the abacus, we can actually scale it. We can actually say 550, right? 50 plus 30 is equal to 80. This auto clicker is awesome. Giving you oh, thank you so much, LD. Thank you so much. That is awesome. That is awesome. I'm trying to get an auto clicker too. I'm waiting for mine to come in the mail. They misplaced the first one. I was like, no. So this is 80. You could do the dots, but that's a whole lot of dots, and that's difficult to see. You know what I mean? So, and then we can actually do it one step further. We can actually do 500, 500 plus 300, 300. So it gives me 800. See that? So what we're doing, thank you, Dave, for the tiny. So, thank you so much, LD. Thank you, everybody, for liking the live. I do appreciate it. I do appreciate it. So then we have our next number. If I wanted to add, I know how to subtract. If I have 4 on the abacus, I want to subtract the 1. The way the book is broken up is that we always look at the second number, right? The second number is what's going to tell us whether or not we're going to subtract or add. And then we want to take away, so we want to do that. If I want to do 3, so we have 4 on the abacus, I want to take away 3. All I got to do is take away these 3 beads. And it's the same thing. So we have the 5. 5 is the top bead like that. And then I have the 3. If I want to add the 6, notice 6 is what? 6 is 1 bead on top, 1 bead on bottom. You bring it together, that's what 6 is. But guess what? If I have 3 on the abacus already, when I add the 6, I'm going to add 1 bead on top and 1 bead on bottom and bring it together. And so my final answer is 9. Hello, Michael. Hello, Michael. Thank you so much for checking in. For those of you that are interested and you want to be a part of my community, there is an orange heart right around my head that you can check in. Yes, thank you. And so we have 9. So notice that we have enough beads. Well, we're going to keep going. We're almost done. So we have 1 on the we have 7. 7 is 1 bead on top, 2 beads on the bottom. That's what 7 is. Now, when we're looking, right, we want to add 1 on the abacus already. And want to add the 7. When I add the 7 again, it's only 1 bead on top, and 2 beads on the bottom. You bring it together. And my final answer is 8. And then we have and then we do 8 or 9, right? 9 is just bring it together, push it apart. Bring it together, push it apart. And that's it. That's it. Okay, so now we're going to go into the formulas. Thank you so much for your patience. Oh yeah, before I forget. So the other thing is the mainstream math is they're telling the kids that they need to memorize how to make a 9. But in Abacus World, we don't need to memorize how to make a 9 because it just shows us. So if I have 1 on the abacus, I want to add the 8. There's enough beads to add the 8. I don't need to memorize that. So it's the same thing with the 4 or the 3. If I have 3 on the abacus, I just want to add the 6. I just have enough. I don't need to memorize how to make a 9. And that's it. Thank you so much for liking the live. So we have our next one, right? Now we're going to go into how to make a 5. NC visual? Yes, thank you. NC, is the formula of how to make a 5 what you're talking about? Okay. So this is how to make a 5. Now, what we're going to do is we're going to understand how to make a 5. This is a simple question. It's a super simple question. But you know what? This is one of the core concepts that we have. We have a 4 and a plus 4. So we're not going to memorize 4 plus 4. We're not going to memorize 4 plus 4. What we're going to do is we're going to understand the concept. We're going to have the 4 on the abacus, right? And I want to add the 4. Now, there's not enough beads to add the 4, but guess what? I don't want to do this because that would just be 44. In general, I'm having a hard time with -4 or -4 -6 or whatever the number is. So that means you're having problems with the -10s. Okay. We can go into that. Let's talk about this, and then we'll go into the -10s, because we need to add in order to subtract, right? So here, if I do 4, we have 4 on the abacus. Here's another way. So we have 4 in the abacus, 1, 2, 3, 4. And then we want to do is we want to use the 5 to give you, right? Just like a nickel. If I give you 5, I need to take away 1 because that's too much. So my final answer is 8. 5, 6, 7, 8. Right? I can do it again on the abacus. I can add the 5, but take away the 1. So my final answer is 8. Okay, let's try this way. Let's see if this one will help. We have 4 on the abacus. And this is why we look at the second number. We have 4 on the abacus, like that, right? We want to add 4. What does mainstream do? Mainstream counts up. They say this is 4, and then you have to memorize your doubles. Oh, okay, whatever. So, or the other one is you have to count up. 4, 5, 6, 7, 8. You can count up. But you know what? We know the concept of how to make a 5. We know the concept of how to make a 5. We have to add the 1. 4 plus 1 is equal to 5. So what are we going to do? Where are we going to get this 1 from? We are going to get the 1 from the first number. The second number is where we want to make the 5. We want to round it up to 5. So when we want to round the second number to 5, we got to add the 1. But there's no beads to add the 1. Where are we going to get the 1 from? We got to get the 1 from the top bead. We're going to give away the top bead. We're going to give away 1 from here. We're going to give away 1. Because we gave this away, we can add it to the bottom 4 to make this a 5. So now my final answer is 8, 5, 6, 7, and 8. We can do it again on the abacus. We add the 5 up top. Does that make sense? Why are we doing that? Because it's the second number that we're going to round up. Give away the 1, yes. Give away the 1 and add the 5, yes. So just like drifting, right? You need to add in order to subtract, or you need to subtract in order to add.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So this is the other one, right? We have 3 on the abacus. It's the same thing. I want to make the 5. I want to make 5 out of this 4. I want to round this 4 to 5, right? I want to round this. But in order to round it, in order to go up to 5, I need to have 1. So because I have 1, where am I going to get it from? I get it from the first number. Because I get it from the first number, I got to take away from the first number to give it to the second number to make my 5. So my final answer is 7. 5, 6, and then 7. 5 plus 2 is 7. I think because I'm relearning how to do math, that's why all the formulas are a little bit hard. You know what? Instead of thinking them as formulas, think of them as partners. So what are the partners, right? The partners is 1 and 4, 4 and 2, 3 and 2, and 2 and 3. Think of them as partners, like complementary numbers. If you think of them as numbers, then it'll be easy to know the reciprocal. Does that make sense? The constant will always be either the 5 or it's always, the constant will always be the 5 or it'll always be the 10. So when you're looking minus, right? The complementary number is the 6. Here's another way. So when we're looking, thoughts of using hands, you could. So, okay, so let's do another one. So if we did minus, right, we have 5, 6, 7. We have 7, right? We have 7 over here. You know what? I'm going to need to change that. We're going to have 7 over here. I want to subtract 4, right? There's 7 right here, right? 5, 6, and 7. 5 plus 2 is 7. There's subtraction. So now what happens? I want to subtract 4. To subtract 4, I take away 4. I got to break the 5. I got to break the 5, and then this one becomes part of the collective, and it comes here. So I break the 5 to make, but I have a leftover. I have a leftover 1. Does that make sense, NC? So when we're looking, you're either making a 5, breaking a 5, making the 10, or break the 10. Make a 10 is what? Carrying over, and borrowing is minus. So when we're looking at it, even when we do the bigger numbers, let's say we do 7, 8. Let's do 8, right? We do 8, and we want to plus the 4. We add the 4. Here's my 4. But guess what? There's not enough beads to add the 4, right? There's no more beads to add the 4 to the abacus, right? See how there's no more beads? So what do? Well, you know the complementary number is here. The complementary number is 6. Where are you going to get the 6 from? The 6 is going to come from the 8. So you take away 6 from the 8 to make a 10. So you take away the 6 like that. So I have 2. I've made a 10, and I add my 10. So what we're doing is we're doing the complementary numbers. It's just a little bit about balance. We can do it again. So that's the other thing. In abacus world, we don't take the 8. We don't take the 8 to make it a 10. Because where are you going to get the 2 from? right? No. Yeah. No, you don't get it from, no. Like, what I mean is, the question is here. The question is here. In mainstream school, in public school, they have this number. What they say is, well, 8 is close to 10. Yeah, then we carry. The carrying over just means that we're going to add a 10. Carrying over means 10. That's what carrying over means, right? But the problem is mainstream math, they're like, okay, you have 8 on the abacus. You have 8 on, oh, you have 8. In mainstream school, they're like, okay, well, we know that 8 is close to 10, so we make it a 10. But the problem is where are you going to get the 2 from? Is it from the ether? It's not. Abacus does it the other way. Yeah, Abacus does it the other way. We have the 8 on the abacus. I want to add 4. This 4 has no more room to add it, so we got to break the first number to make the second number. So just as I showed you, we have 8 on the abacus, right? But we don't make this one a 10. We need to make the bottom number, the second number needs to become a 10. So it's actually minus 6. So you minus the 6 here to plus the 10. It's a little bit, it's a small switch, but it's a very powerful switch. You don't try to make the 10 at the first number. You try to make the 10 at the second number. Does that make sense, LD? And that was the other thing I was talking to my friend about. He mentioned that kids don't need to memorize 10 times 10, the 10 tables, the times 10 tables, because it is redundant. And they're starting to see the difference. But I don't know if the teachers understand. In Abacus world, we don't need to go higher than 9 times 9 because everything else after that is just distributive property. So, LD, did that make sense? You have the 2. No. Because where's the 2 going to come from? The 2 has to come from somewhere. No. It's the 4. Hello, RTX. Hello, RTX. Hello.
Welcome to the real world.
So we make this, right? Hello, Diego. We make this, the 4, a 10. So we have to take away the 6 from the 8. Make it a 10. That's your carrying over. So now this becomes my 10, and then I'm left with 2. We could do it again. Let's do another one. We'll do 3. Right? So the reason why I'm showing you with the small numbers at the bottom, because we'll do 8. The reason why is because the mainstream school, they always want to say, well, make this is closest to the 10. Yes, minus the 6. You're right, minus the 6. So now we have 8 on the abacus, right? We have 8 on the abacus. I want to add 3. I have no more room on my abacus to add the 3. Guess what I'm going to do? I got to make 3 a 10. How do I make 10? I know it's going to come from seven. Yes, thank you, NC. Yes, 7. Right? 3 plus 7 is equal to 10. Thank you, LD. Yes. So we take the 7 away from the 8. Right? We take it away from the 8 because we have it. We know what's there. We add it to the 3. Now I've made a 10. So my final answer is what? 11. I had to think about that because it's 10 plus 1 is 11. What math is this? This is basic math. We're talking about basic math. It's not, yeah, it's 11. So the difference is, oh yeah, this is the way.
This is the way. This is the way.
Right? So what we're doing is we're understanding concepts. The concept is you need to subtract in order to add. That's the concept, right? Just like drifting. You need to turn right to go left. I need more practice this is this way more. Yes, it's a different way of thinking. It's very different than mainstream math. And I know this because I was talking to my friend, and he is a second grade teacher, and he was making new pathways when I showed him this way. Because the problem is they keep showing you the top bead, but the top number is not where it goes. It's always the bottom number. So Abacus focuses on the bottom number. Hello, Doug. Thank you so much for joining. Hello, hello, hello. You know what I mean? So when we're looking, always look at the second number. Always look at the second number. The second number is what's going to tell you whether or not you need that formula. It will happen. It's just, yeah, you're right. It will happen. It's just all about practice. So like this one right here is 6, right? We have 6 on the abacus. Can I add the 3? Hello, SpongeBob. Can I add the 3? Yes. I don't need to I don't need to use a formula. So there's no overkill. You know what I mean? So 1, 1, 1. That's 3. 6 plus 3 is 9. Ha! Thank you, Doug. Right? So, and 3 turns into, yes, exactly. 3 turns into 10 minus 7. You're absolutely right. So you plus the 10. So that's what we're doing, right? It's plus the 10 minus the 7. Oh, my beads are a little sticky. So when you're looking, and that's why I would say it out loud, and I would move it. Plus the 10 minus the 7. So my final answer is 11. Thank you, Doug, for the tiny diny. Thank you so much. Make sense? So when we're looking, right, you just need to know your complementary numbers. You should know that 2 and 8 is a 10. You should know that 4 and 6 and 1 and 9. All of this makes a 10. And then on the other side, you need to know that 1 and 4 makes a 10. 1 and 4 makes a 5. 3 and 2 makes a 5. 2 and 3 makes a 5. You need to know this. When you know this, right, then you can do this at scale, and it doesn't matter. So, I mean, we could do the 8, same thing. So we have the plus 10, we do 8. But guess what? Let's do 4 plus 8, right? We have 4 on the abacus. We have 4 on the abacus, and 1, 2 plus the 8. So we have the 8. This is where it would be, okay, this 8 needs to be 10. Thank you so much. Yes, thank you everybody for tapping away. So when we're looking, this is 8. So if this is 8, what are we doing? We take 2 away from the 4. Take 2 to make 2 away from the 4, and then you add it to this 8, and we've made it 10. Yes, thank you. Hello, Crispy. Thank you so much for the rose. Hello. Yes, and you add the 10. Add the 10. Make sense? So it's different, not difficult, unfamiliar. It will become, but you gotta, I would say it out loud, because the more you say it out loud, the easier it is that the easier it becomes, following along, thinking, oh, good, right? It's not, yeah, it's different. Exactly. It's different, but the same. Exactly. It's different because Abacus focuses on the second number. Don't look at the first number, stays as it is. And we take it away from here. You take from what you've got, right? It's different, but it's the same. Because the same is what? The same is, we know that 8 plus 2 is equal to 10. I'm struggling with this one. Yeah. So if we did 6 times 4, there's 2 ways you can go about it. There's 2 ways you can go about it. You can either, let's see if this works. You can either do repeated addition. So we have 4 times 1 is 4. 4 times 2, add a 4 here. How do you add a 4? Plus 4 is equal to plus the 5 minus 1. plus the 5 minus the 1. 4 times 3 is 4. Add a 4 here. How do you add a 4? Keep the change. Thank you so much for the rose, crispy peanut. How do you add a 4 here? We talked about it. Plus the 4 is equal to what? Can you add the 5? No. What do? How do you add a 4 here? Nobody?
Bueller. 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 Bueller.
Thank you, Michael. Yes, plus the 10 minus the 6. So plus the 10 minus the 6. Right? Thank you, LD. So then we want to add another 4. So 4 times 4, right? We want to add another 4. Can you add a 4 here? Oops. Can you add a 4 here? No. There's not enough room to add the 4. What do? Plus 4 is equal to what? Plus the 5 minus 1. Plus the 5 minus the 1. And then we have this one. 5 times 4. 5 times 4 is what? How do you add a 4 here? Can't do it. What do? Plus the 4 is equal to plus the 10 minus the 6. Plus the 10 minus the 6. And then add a 4. So we're at 4 times 6 is 4. So you could do repeated addition. It's up to you. Or you start memorizing. I usually, the way I teach my kids is I tell them to do it on the abacus so they can see it. Every number they can see and how they move it. And as they do it, they get tired and they start memorizing certain things. So there's certain things that you would know, right? So sometimes you would gravitate to some of the numbers that you like. So so this one here, like 5 times 4 is equal to 20. So if 5 times 4 is equal to 20, then I know that my next number would be 5 times 6. All I have to do is add a 4. So that would provide some number flexibility. I don't know if that made sense. So, wow. How did I know that? I haven't even practiced multiplication yet. Can you do something like 6 times 2? Yeah, it's 6 times 2. So we have 6, right? 3 times 3 is 6, right? Plus the 9 is plus the 10 minus the 1. So my final answer is 15. It's just basic arithmetic. You do basic arithmetic on the abacus. So, hello, Matt. On the abacus, this is 5, this is 1. Anytime the beads are touching the horizontal bar, they're considered counted. So we have 5, 6, 5 plus 1 is 6, this is 16. Because we have 1 here, this is 6. 1, 6, and then we have 7. This is 17. 1, and then 7. 1, 7, right, is 17, and then 18, 19, and then 20. This is so good. Oh, good. Oh, good. Yeah. So in this book, the one that you have, LD, is inside here. So what we're doing is we're understanding repeated addition for multiplication. That's what it is. Okay, I was wondering the values. Can you tell? So, here we go. So, Matt, thank you for the question. There's a dot right here. This is my label. This label tells me that this is the ones place. So, it looks like that. We have our ones, our tens, hundreds, thousands, and 10,000s. That's what we're doing. And notice that we have our decimal is over here, our tenths, and our hundreds. Thank you, everybody, so much for liking the live. We're at 18,000. 18,000 rocks. Thank you so much for the share. So, okay, I'm only on page 22. Yeah. No. Yeah, even on page 22, it's still good. But it's such a... I do like this book. It's a packed book. I will tell you, it's packed full of information. But if you could just go through the questions, I think it would work out really well. And I just started working on the multiplication book too. Oh, Michael. Yeah, not a problem, Matt. So when we're looking, right, we could do this number. We can do this number over here. So this would be a whole row of fives, right? That'd be a whole row of fives.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So this is 55,555.55. This is a whole row of fives. We can do a whole row of six, right? That's what six is. So then you might be wondering, well, what about nine? Well, this is nine, and then what's after 10? 10 would be like this, 1 and a 0. And then we have I thought about teaching videos? Yes. I have videos. I have an online class that I teach kids. Yep, it's part of my membership. I was going to extend it. Here's the thought. I was going to extend it to, if you buy the book, you can purchase the videos. But I haven't gotten there yet. Hello, Melinda. Yeah. So that was the other thing I was going to do is maybe what I'll instead of doing a membership, what I was thinking about doing is if you buy the book, you can buy the videos, and the videos will be for yours. And then yeah. Yeah, it'd be like an additional cost. That's what I was thinking. That would be like the next step. So I just haven't built the video. I have videos for four of my four. I have videos for four of my books, and I got to do 10 more because I have 14 books that I published. And so I've been actually publishing my books more than I've been doing my videos. So, yeah. But I think what I'm going to do is I'm going to make this, I'm going to make a video, a video playlist for this one. And that'll be an additional cost. That's what I think. Sorry. Oh, thank you so much. Thank you so much, Melinda. Thank you so much. Have a good night, and I'll see you in my next live.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Yeah, and see what? Yeah, that's what I was thinking. I was thinking about doing a. I like Patreon. More of that is nice. This one would actually be in the individual books. So I was actually making an individual book for the kids. It would be grade one. I'm doing grade one, book one. So it'd be it. So that's where it would go. It'd go like right here. And that one is because it's not. There's no formulas involved. I was thinking about homeschooling my toddlers with the abacus. Okay, I think that might be the better route. I think that would be a better route if I did the videos and then I like having to read and get the answers using abacus. Oh, I see. I see. Read the abacus. That's interesting. Okay. Practice on that. All right. I could see that. Okay, that's a good one. My son enjoyed it very much. Oh, good. Oh, good. I'm excited. I'm excited. It's okay. That's an interesting thought. I wasn't thinking. Okay, that's a good one. I just thought that they would get tired of reading the abacus, but and then write the number. Yeah, I get you. I get you. Like that. Yep. That was a new thing that I did. I didn't do it for my previous books. Okay, that's really interesting. Okay. Um. Yeah, I don't do it for the rest. I only do it for the beginning parts, because then we start transitioning to the actual numbers themselves. All right. So I guess that would be another thing. Okay. I could. It would. The only thing is it would take time. Oh, I know how to do it. I don't know. I have to think about that one. Yeah, I'd have to think about that one. Um, I've lost my train of thought. Okay, there we go. Write the number and solve the equation. Yep, I get it. I get it. Yeah, I was just trying to think of how to streamline it. Because it does take time. And I guess what I could do is just convert all my books that way. But then the problem is, like, then you don't get, like, activities like this. You know what I mean? Because I could see it for, like, this. I could see it for something like this, like, say, hidden words. I could see that. But then the problem is like, something like this, it'd be more difficult. Because it would just take up too much space. I could see it here. Okay. Interesting. Okay. That's something to think about. Thank you, LD. Maybe just worksheets. Yeah. No, that's something to think about. I can work it into other places. I could see that. Okay. Sorry. Okay. Thank you everybody for joining. Thank you everybody for joining. What we're doing is we're learning how to read the abacus. So, I mean, we can continue on. Just like here. Again, what we're doing is we're focusing on the second number. Right? Yay, ideas. Yeah, thank you. What grade would you teach math in? What grades do you teach math in? I teach the fun grade, ZXCNN. So if we have 8 on the abacus and want to add the 7, right? When we add the 7, what do? We know that when we make a 7, we want to make that 7 to a 10. There it is, right? See, now it's being demystified. The upgrades. The upgrades. Right? It's being demystified because you now know if I need to add the 7, all I need to do is add the 3. So we got to do is we minus the 3 and then plus the 10. So my final answer is 15. So, second grade to 7th, 8th, yeah, this isn't my math. I'm a sophomore. Oh, that's fine. I've had high schoolers that come into my class and they think that it's really great. This is just basic arithmetic. We're just doing math. We're just doing adding, subtracting, multiplying, and dividing. But I do have high schoolers in my group. So don't be judgy. ZXCNN. Very judgy. I don't know why people judge all the time. I don't know where this judgy comes from. Yeah, I don't know why people are judgy. They're so judgy these days. Night. Ah, great, NC. How you're so patient teaching. I'll try to catch you at the next live. Okay, not a problem. Yeah. Thank you so much for joining. Thank you so much for joining, and I'll see you in my next live. So we're gonna do this one. We'll do 91. 91. Can't see that. Okay. 91. What do we do? I'm pushing 30. I find any. Oh, never to learn. No, it's never. It's never to learn. It's never. You're never too old to learn, but you also need to keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
You're right. People fear what they don't understand. And that's what the other thing is I'm trying to do is I'm trying to demystify the whole abacus. You know what I mean? Because it's really interesting on how it just works. And the fact that you could see your numbers, you can do a lot more. Fearing of upgrading the brain matter. Oh yeah. There was this one there's this one person that came into my room and they're like, my brain hurts. I go, oh, that's because you're doom scrolling too much. And abacus stops your brain stops makes your brain active. So it's like because the brain is like a muscle and you haven't been using it, so the brain keeps you active. All right, so Matt, I forgot where we are. I've just been kind of jumping all over the place. I was doing this one. So we have 91 on the abacus, and we want to add the 1 and we add the 6. So when we're doing an abacus world, we actually take the number as a whole. And so I went to work 14 hours ago and you were doing this. Yeah, I'm doing it again. How long have I been on today? I actually just came back on.
Gee, Ray, what do you want to do tonight?
Same thing we do every night, Pinky. Try to take over the world.
So we want to add the 1 and 6. What we do in Abacus World is we take it as a number as a whole. I go from left to right. You could go right to left. It is up to you. I'm not here to judge. But I like to go left to right because we say 16 and not 1 6. Thank you, baby Hazel, for the tiny diny. So we add the 1. Notice I have no more room to add the 1, right? So what am I going to do is I'm going to plus the 10 minus the 9. Right? How do I know? Because we know when we want to make 9, because 1 and 9 equals to 10, right? We minus the 9 plus the 10, and then we want to add the 6. Is there enough? Yep, add the 6. Plus the 5 plus the 1, and that becomes 6. So my final answer is 107. And that's it. All right, so let's go back a few. Because I've been kind of all over the place. So there's more to it, right? We can actually do multiplying and dividing on the abacus. But the biggest thing is to understand the fundamentals. The fundamentals is understanding how to make a 5 and how to make a 10, right? So the first thing we're going to do is understand how to make a 4. We've done that. How did that work? So remember when we do this, we do 4, right, on the abacus. I want to add another 4. Cannot add a 4. What do? Well, in mainstream math, you count up. But we don't want to count up. What we want to do is we want to utilize this formula. The formula, we know the concept is 4 plus 1 is equal to 5. We know this concept. So what happens is I'm going to take away 1 from the top and I'm going to add it to my bottom. The bottom one is always what we're going to do. The bottom one is where we want to make a 5. So this becomes 5. So my final answer is 8. 5, 6, 7, 8. 5 take away 1 is equal to 8. So we understand how to add. Now it's the opposite. If you want to subtract, what do? We have to break the 5, right? Break the 5. Take away this 4, and this becomes part of the collective. That becomes, you add it. So we take away the 5 and you add the 4. Then my final answer is 4. That's how you go reverse. So if you know how to add, you know how to subtract. Because when we are adding, it is plus 4 is equal to plus the 5 minus the 1, right? But then when we're subtracting, it's minus the 4 is equal to minus the 5 plus the 1. So see how see how the signs are reversed? They're exactly the same numbers, but it's reverse. It is so much easier on the abacus visually. Yeah, it's really crazy on how easy it gets. And the more you see it, the easier. Obviously, the more you see it, it's just crazy on how easy it is. So here we do 4 and 3, right? We have 4 on the abacus. I want to add the 3. To add the 3, what do? Well, I know I want to round 3 up to 2. What do? You got to take 2 away from the 4. Take 2 away from the 4. And then you add it to the 3. Now I've made a 5. What did I do is I regrouped at a smaller level. I have a regroup at a smaller level. So what we have is we have 5 and then 6 and 7. So what we're doing is we're having this concept of taking away to subtract. Lord, please give me children when they revert back to normal math. What? I don't understand that. Give me children when they revert back to normal math. When they revert back to normal math. I'm not sure what that means. Because this is normal math. This math has been around longer than new math. Okay. So when we're looking, right, we want to do is we want to round up to 5. And that's what the concept is. So we know 4 plus 1 is equal to 5. This is all you need to know. And we could do it again with a 3. We don't need to memorize 3 plus 3. My friend was like, oh, I'm going to be teaching the kids how to make a double. I was like, you don't need to. In Abacus world, we just need to know is how do you make a 5? 3 plus 2 is equal to 5. Like, you mean they teach? Yeah, I don't. Yeah, right? I don't know. I don't know what Jordan's talking about. So, again, we have 3 on the abacus. We have 3 on the abacus. What we're doing is, even as a nursing student, this makes 0 sense. Oh, Jordan, is it because you just came in and we're talking about in the middle of my live? Like, I've been on for about an hour or so. I've already talked about the beginning parts. So that's very judgy. That's very judgy. Slide the blue down. Yes, thank you. Slide the blue down. It becomes 8. But you have to take away the 2. You have to take away the 2. Why? Because 5 plus 2 is equal to 3. I'm sorry. 3 plus 2 is equal to 5. 3 plus 2 is equal to 5, right? So you got to make this as a 5. So take away the 2. And now that becomes 6. Does that make sense? Diggy? What? 2. We're doing 3 plus 3. This isn't modern math. This isn't modern math. This is not modern math. This abacus has been around since the 1600s. I didn't mean to ruin. Oh. Okay, thank you, Jordan, for the apology. What? 2? Diggy, did that make sense? Abacus is basically the original calculator, yeah. So, wait. I'm confused. We have 3 on the abacus. We want to add this 3. The bottom 3 is what we're going to do. We got to make this up to 5. So we know 3 plus 2 is equal to 5. Abacus was not invented when Obama was president. Come on, Diggy. No. 1600. It's been around since 1600. Those kids that do this, they're doing abacus. That's what they're doing. You know, there's that one world record person. He was able to do addition, 100 lines of addition under 30 seconds because he's doing this with the abacus. So we're going back to here. Understand that when we make a 5, we know that 3 plus 2 is making a 5. Let me Google abacus. Okay, you go do that, Diggy. So we have 3 plus 2 is equal to 5. So what do? This is my 3. This is the 3. The bottom 3 is we're going to round up to 5. So what we're going to do is we're going to round up to 5. To do that, we need to get the 2 from somewhere. The 2 has to come from the top bead. The 2 has to come from the first number. So you take away the 2 from here, and then this becomes... So what we just did is we did a little step of rounding, and that becomes 5. So we have 5 plus 1 is equal to 6. So Jordan, let's go back a little bit and let's start looking at the abacus. Here's how you read the abacus. This is how you call 1. This is 2. This is 3. This is 4. That's what 4 is. Does that make sense? Hello, Nazar. Thank you so much for checking in. Math is gods of language. So we have 4. The top beat is a value of 5. No matter what, the top beat will always be a value of 5, no matter what. This is 5. This would be 55. This is 555. This is 5,555. This is 55,555. And then you might be wondering, well, what about these two? Well, they come in decimal places because every column is a place value. We have our ones, our tens, hundreds, thousands, and 10,000s. Then we have our tenths and we have our hundreds. So this is our decimals. Why? I have a label. This label tells me that this is the ones place. This ones place tells me that I'm going to use this to count. I have two labels, one here and one here. This is another label. This label tells me this is the thousands. So it's a readability. I could say 3,000. So if I did this, notice there's a comma just for readability. That comma is there for readability. So 3,456. That's what that would look like. So we have our 6. 5 plus 1 is 6. We have 5, 4, 1, 2, 3, 4, and then 3, 1, 2, 3. So when we're reading the abacus, the biggest thing is to understand how to read the abacus. Oh, Diggy. The Japanese came around in the 16th century and modernized it. So the abacus in this one is around 16th century. Because it's been the 16th century, the abacus, this is the soroban. Yes, an abacus itself with the 10 beads was been around since the 2600. Then there is the Chinese abacus. So the Chinese abacus has been around before the Japanese abacus. So when we're looking, this was before the Japanese abacus, but the Chinese abacus did counting up. So when we're looking, when they do their adding, they're counting up. Whereas the abacus, the soroban, we're using concepts. A true artist never blames the brush. What? I simply never heard of an abacus before. That's all right, Jordan. I agree. I understand. We're in 2025, not 2000. Oh, Diggy, so it's fake. All right. Jordan, it's kind of dope for coming around and doubling down. It's different because it's different because you can visualize your numbers. So now when we start looking at it, then we start going into other things. Because now you know how to read the abacus. You can kind of see it, right?
Oh, I can see everything.
So then we would have this one where you could teach the kids. I was trying to get the kids a little bit younger. This is meant for like 3 years old, 4 years old, 5 year old. The reason why is because I wanted to introduce abacus while they're learning their numbers. Just like they're counting on their fingers, they're counting on their they can count on the abacus, and so that's what this was meant for. And so when we're looking. This is just, understanding the numbers, just recognizing what the numbers are. And then we count about the relationship of the numbers. We count backwards, we count forwards. We try to understand the numbers that comes in between and so forth. And then we do a little bit of comparison. And then after that, we start going into adding and subtracting. So the adding and subtracting is different in mainstream math compared to abacus math. Because in mainstream math, you focus in on the result. Whereas in the abacus math, you focus on the added. Hello, Silver. Thank you. I'm always open to new ways. Oh, yeah. I've never learned how to count. Abacus is a lot more sense regarding finger math. Yes, you can do finger math. It's a little different because we can scale it. So on the abacus, we can do 7 on the abacus. And then you can subitize. Subitizing means that you can look at the number and you know what it is. So this is 7. How do I know? 5 plus 2 is 7. And then I want to add the 1. Adding of the 1 is the question is, do you have enough? Yes, we have enough. Can we do it?
Yes, we can.
We can add the 1. So my final answer is 8. When we're looking, right, that's what we're doing. We're just adding this 1 bead. So it doesn't matter what bead you're adding. You're just going to add the 1 bead. Right? Because you could see it. So we could do the same thing with the 2. We have 6 on the abacus, right? We have 6 on the abacus. That's what 6 is. We want to add the 2. We add these 2 beads. 1, 2. And that's it. So each bead under is worth 5. Yes, exactly. Each bead under here is worth 1. So when we're looking, we have 1, and you add the 5 is 6. You have 2, you add the 5 is 7. You have 3, add the 5, it is 8. You have 4, 1, 1, 1, 1. 4, add the 5, it is 9. Does the Chinese one differ? Yes. Is it more complex? No. It's just a little more redundant. So the Chinese abacus is very similar. And what Japanese people did is they made it more efficient. So when we're looking, we do 1, 2, 3, 4, 5. And then we can trade this in and make this a 5. That's 5. The top beat will always be 5. If you're thinking about, if you want to be poetic, the top beats are the heaven beats, the bottom beats are the earth beats. So we have 5, 6, 7, 8, 9, 10. This is 10. So you trade this in to make that a 10. You trade this in because this is 10. This is 5 plus 5. This is 10. You trade that in and that makes 10. So this is 10, 1, and a 0. Honestly, this is great information to learn. Jordan. I'm just laughing because you came in and you didn't. Yeah, it just takes a little bit to understand. It doesn't, it just takes a little bit. I prefer the Chinese one. Okay, Redux. That's funny. Jordan, you're funny. So we continue it on, right? We can continue on. Here is 5 plus 3. We could do 5 plus 3, right? In mainstream, you could do the dots or you could do the tally marks, which is fine too. But in it is different. I understand. It is different, and I get a lot of people coming in. But funny, people don't think I'm gonna cook them. Some people turn around like you do, and some people don't. But I appreciate that. I appreciate you take the time to understand. I do appreciate your time. So we can actually scale it. We could do 50, right? 50 plus 30 is equal to 80. Kind of like North Korea. Thank you, desert. Yes. It's kind of like the Roman numerals. So if we're looking at Roman numerals, we have 1, 2, 3, 4, 5, 6, 7, right? 5 plus 2 is 7. We have 8. 5 plus 3 is 8. We have 9. Kind of 9. Like 5 plus 4 is 9. And then we have 10. You could do the tally marks, right? 1, 2, 3, 4, 5. 5 has a slash. 5, 6, 7, 8, 9, and then 10. Yep. Yeah. So we're going to continue on. And that's the thing. The difference is what? If you know how to add, you know how to subtract. Well, what does that mean? In mainstream, there's a whole unit on subtraction. But in Abacus, we don't need to worry about it. Because if I have 2 on the Abacus, I want to take away 1. All I got to do is take away the 1 like that. Right? What grade do I'm trying to introduce it to grades preschool, kindergarten, 1st grade, 2nd grade, 3rd grade, 4th grade, 5th grade. I think I can go all the way to 5th grade because 6th grade they start doing geometry and algebra and so forth. So the problem is Abacus doesn't introduce at those levels, and that's what I'm doing. I'm trying to introduce it to those levels because everybody needs to understand how to. I just got to make it more accessible. Typically, the kids are young. The kids are usually about 5 or 6 or 7. That's kind of the sweet spot. But I actually made it a little bit more. I was trying to expand it a little more. That's why I created a preschool book, and then I will be going into 1st grade, 2nd grade, and 3rd grade, and 4th grade and 5th grade books. Yeah, that's the plan. But it does take time to curate all the questions and to be able to get the books out. So right now I have 14 books that I've published. Excuse me. Wow. As soon as preschool is awesome. Yeah, I try to. I think it's a great tool. Thank you, Jordan. They've always wanted to use their hands too. Yeah, and the difference is on the Abacus and these little bricks is that organization. And so if you have a classroom full of 30 kids, it's difficult to manage with these bricks and all these kids. Whereas on the Abacus, it's all done for you. It's all organized. And then the other thing is like if the kids have ADHD, they don't know how to organize their bricks well. And so the interesting thing is the Abacus, it doesn't matter as long as they don't move the beads, then they'll be able to read it and they'll know where to stand off. So as an autistic guy, I think the tactile nature help. Yeah, and yet that's the other thing. So I'm sorry. So you have done this yourself? Done what to myself? And so I don't understand the basic question. How do you know the beads are counted on? Whenever the beads are touching the horizontal bar, that's what's being counted. So this is 1, this is 2, because they're touching the horizontal bar. When I have 5, the top bead will always be 5 wheels. And so we have 6, right? 5 plus 1 is 6. And then, oh, I see, yes. Yeah, these are all my books. Yeah, these are all my books. I have an adult book too. So this is me. Hi. You created the books and lessons. Yeah. Yeah, that's all me. And so the way I've created it, yep. These are all I mean, there are other books out there, but this is what mine are more interactive and more entertaining. So what I did is I created all these activities for the books, for the people to learn how to use the abacus, and then there's like teaching as well. So there's like color by number, there's a word ladder, there's mazes. I like mazes. Everybody likes the mazes, so I think the mazes are kind of cool. Color by number, mosaic, yeah. And so I built all of my books, every one of them. Oh yeah, there's the mazes. Yeah. So I love the interactive. Thank you. Oh, thank you. As part of a time for the nanny is definitely a post. Yeah. Everyone pull. Thank you, Redux. Oh yeah. Oh yeah, yeah. Oh yeah, wheels. This is for wheels.
Oh, I can see everything.
Yeah, so this was my first book. Before I started getting onto TikTok, and then I'm like, well, let's see what happens. So understanding how to subtract, right? Again, subtraction is very similar. If you know how to add, so I added 9, I want to subtract 3. To subtract the 3, all I got to do is take away these 3 beads. So when we're looking, right? When we're looking, we're just taking away these 3 beads. So our final answer is 6. It's very different than mainstream math. Mainstream math focuses on the result, but the abacus focuses on the second number, the number that we're making our operation to. So we have 3 on the abacus, 1, 2, 3. We have 3 on the abacus. I want to add the 5. All I got to do is add the 5 like that. If I want to take away the 5, I just move it away like that. It's not very difficult. You just do the inverse, right? You do the adding, you do the subtraction. Does the Halloween abacus come with the abacus? You can order it with an abacus, yes. And so, just so you know, that one is only adding, is not even adding. That one is just looking at the numbers. So here's a little flip through of that one. Hello, Asbury. Hello, Asbury. How you doing? How you doing? Yeah, Asbury. How's school? You started school, right? So Jordan, for the Halloween one, so what I did is I have it where there's scissor skills. So trace it first and then cut it. And then I had some kids that color it in. And then we talk about how to read the abacus. This is just find the abacus, get used to what the abacus is. And then this is the number. My girl nanny is a kindergarten, so she doesn't need too much, but she loves Halloween, so I think. Okay. Well, this one's kind of interesting because I made it where there's a maze, and they would have to practice their writing. That's what I did here. And then this right here, because there's a empty space, add the dough balls, like Play-Doh. So it would look better, it would be better on this one, number 3. So trace all the numbers and trace the words. The idea was to get them to understand what the words are, and then they would have to find the number 3. So this is 3, this is 3, this is 3, and then there's this one. The idea for the empty space is that they have to put like 3 things in the middle. So if you had Play-Doh, put 3 Play-Dohs in the middle, and then you find the 3, and then 3, and then 3. It goes all the way to the finish line. But I'm not tired, and we've already may have school picks. Have you tried counting sheep, Asbury? And then again, there's more scissors. So have them use the scissors, practice their scissors, and then we only go up to 10. but we're not adding here. We're just showing you, I'm just showing you how to count up to 10. So this one is cut them up into little squares and then match it with this. And then that goes into the spooky pairs. And then I have this one, which is like the clip art one. Not clip art, it's the clothespin one where you have the number. So you trace the number, trace the word, and then here's the clip card. And then you can talk about, and then I add the different activities. You can ascend order, descend order. So if you have multiples, right? Ascending the order, descending the order, talk about the evens, talk about the odds. This is 1, so I would clip it as 1. But then you could say, okay, well, what is before 1? Before 1 is 0. So 0 would be here. I didn't do it on this one. But what's after 1? After 1 is 2. So I'd write 2 here. You know what I mean? So there's ways to use the clip card and practice their pinching. And that's what is here. So that's what I have the extra things. Okay, Asbury. Oh my God, 1:30 in the morning. You need to go to bed, Asbury. See you later. Do you have other media in case TikTok gets banned? Yeah, I'm usually on. I'm on YouTube. Let's see if I can find my card. I don't have my card. I don't have my card. And then I have a website. It's in the link. I can't find it. Yeah. Okay, see you later, Matt. Thank you. Thank you for joining. Thank you for joining. Thank you for your patience and your time. I do appreciate that. Practice for so many skills. I love it. Oh yeah. Yeah, I try to be kind of encompassing, and so there's tracing, and then there is comparison, and then that's it. So you have the option to buy the Abacus or not. It is up to you. And then this was like comparison, and then the answers are in the back of the book, but there's no adding and subtracting in this one. This was like my second or third book. But yeah, I think what I'm going to do, I'm going to create a whole line of Halloween. So, do you recommend Abacus even if they don't practice it? I do, because they can practice it at home, and then you don't have to worry about school math. The reason why is because they do some Common Core, and it's interesting because a lot of the kids have problems with Common Core, whereas when my boys went through it, they didn't have a problem. So I don't know what they do in Common Core. I don't know if it's a good thing or a bad thing, but like I didn't have to help them. But I always have to tell them that they have to show their work, whatever the teacher says. And so do they have what they use the Abacus? They use the Abacus to double check their answers. So that was the good thing about it. They would use the Abacus to double check their answers, because after a while they can visualize the Abacus in their brain, or even the method, they can visualize it in their brain. Then it would be easy for them to add and subtract and multiply and divide. So on the Abacus you can do adding, subtracting, multiplying, and dividing. Common Core tries to get the kids to understand the quantities of numbers and to be number fluent. So I think what they're teaching or how they're teaching it is a little bit discombobulated. So, because we're still teaching the kids how to memorize doubles or the near doubles, how to make a 10, but they never really utilize how to make a 10. And so that's the difference between Abacus world and mainstream world, is that we take a concept and we solidify it, and it becomes automatic. So when you saw the numbers, when we were talking about how to make a 5, that's a core concept. And once you know how to add the 5, then it doesn't matter what the number is. So we're doing here, we were adding the 4. We know that when we add the 4, it's plus the 5 minus the 1. Well, guess what? When we have it in a bigger number like this, if I can find it. I can't find it. I gotta find it. I gotta find it. Okay, hold on. Yeah, if you're interested in learning Abacus, I do have I do have Abacus for adults, and that was this book right here. It's a little bit more encompassing, and what it is it talks about all of the different concepts all in one book. It was meant for adults. It would be a little bit of a too fast of a pace, I think, for the younger kids. But that's why I broke it up. For the younger kids, I broke it up into separate sections. So this is adding of the 5. This is minus the 5. What we were looking for, what we were doing was we did the plus 5, the minus 5, the plus 10, the minus 10. Plus 10 means that you're borrowing, and minus the 10 plus the 10 means you're carrying over, and then minus the 10 is you're borrowing. Oh boy. I don't know where it went. Where did it go? So this is the one question I always like to use. So this is a very big number, but because we know the core concept, we have 1,357. I want to add 4,000. 4,000 right here. We know how to add the 4,000. 4,000 is plus the 5 minus the 1. That's what 4 is, right? We know what 3 is. 3 is plus the 5 minus the 2. And then we want to add the 3, and then we want to add the 1. So my final answer is, what's my final answer? What is my final answer? Anybody? So my final answer, hold on. So my final answer is 5,688. That's what that is. Hello, public sphere. Are there abacus you can hold vertically? That's what I see in the cartoons. Yes? That's what this one is. But this is a teacher's abacus. It's smaller. But I don't, yeah. Yeah, the ones in the movies and the cartoons, they're like this big. None of the ones are really meant for vertical. Oh, I actually, you know what? I take that back. Because the vertical ones are horizontal like this. The size comparison. The ones that are horizontal, they're like this. So it's easier to go horizontal, but it's just I don't read like that. You know what I mean? So but yeah. All right. Dorian. Yeah. Oh, here. So an abacus is just a counting tool. It's just it's a math tool that helps you visualize your numbers. That's what an abacus is. And it is a tool. It is up to you. It is up to you if you want to use it. But it is a tool that is out there, and it's different than everything else that we have. And when we're reading it, we have we can do a little review. We can, for Dorian, we can talk about 1, 2, 3, 4. This is 5, and then we have 6, 7, 8, 9, and then 10. That's what 10 is. Yep. And then we have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have our ones over here because we have a label here. We have our thousands over here. So this is the ones and this is the thousands. So this is for readability. So we could do 4,225. That's what that would be. 4,225. I know this because I look at this readability. This would always be my thousands. Yep. Okay. So you don't move the second one beat up for 20? Oh, if that makes sense. If I do the second one like that? No, because this would be 55. 2 and a 0 is 20. So what are the values under 1? There is no values under 1. The value of this is 5. The value of this is 1. So we have 5, 1. Does that make sense? 5, 1, Dorian. So we have 11, right? And then 21, 31, like the ones to the right. Here would be our decimals. So we have our decimals. We have our ones, our tens, hundreds, thousands, 10,000s. And then this would be the tenths and then the hundredths. Yes, you're right, Jordan. So this would be our decimal. Our decimal sits after the ones place, just like everything else, right? Just like when we talk about money, right? Where's my paper? Just like when we talk about money. This is the tenths and this is the hundredths. Just like money. So if I did $2, $2, 0, 5. That's what that would look like. Yep. Easy. Not expecting a mini math lesson tonight. Yeah, it was so funny because there's like a few there's people that come into my live. They're like, you know what? In 2025, never was learning the abacus on the bucket list, which is interesting because it's in the middle of the night and everybody's learning how to math. I mean, there's 150 people in my room and we're all talking about math, and it's crazy. It's crazy, and I guess it's better than just kind of like doom scrolling. But yeah, you're actually keeping your mind active. And that's the thing. The thing is if you like puzzles, you will really like Abacus. If you like Sudoku, crossword puzzles, new information is always good. Oh yeah. So if you like crossword puzzles, word searches, jigsaw puzzles, any of the logical puzzles or whatever, you'll enjoy the Abacus because you are given elements, right? You're given fundamental building blocks to be able to answer questions, and then it's up to you to figure out how to answer it. And so that's why I give you the fundamentals. One of the fundamentals is how to make a 5, and then the other one is how to make a 10, and then you have to figure out how they all fit together. Yeah. I just finished a physics quiz. I know, Alex. I don't know why you're here, but it's kind of nice because it's kind of relaxing, you know. So when we're looking at it, I can do this one. So when we're looking at it, we'll do this one. Yeah, we'll do this one. You'll notice it's really quite simple. It's really crazy on how simple it is. So we have our number, right? If we do 53 on the abacus, right? And then I want to do what? I want to do 20. Add the 20, 2 and a 0. And then here, add the 26. Add the 2, add the 6. So my final answer is 99. You really taught me the abacus on one, like months ago. And I still, oh, thank you. Oh, good. I have too much to do with my nursing. Yeah, I'm going to mention this to my mom. Oh, yeah. Yeah, and that's the thing. It's not, if you have time, and yeah, totally. If you have time, it's great. If you don't have time, I wouldn't worry about it. I wouldn't worry about it. I mean, it's going to be around for it's been around for a very long time. If you yeah, I wouldn't push it on anybody. Like that was the one thing is like somebody would ask me as a high schooler, would I push it? I wouldn't push it. Even like at a later age, unless they're like having problems, I would recommend it. But like if they're older than I say, I don't know, grade 5, grade 4, grade 5, I think then would be like, unless they have time or unless they needed some extra help, I wouldn't really push it, and I'd probably wait till they're adults when they have time to have hobbies. Yeah. Yeah. She's in kinder, so it'll be useful. Yeah, kindergarten is I think the perfect age to introduce abacus because they already understand what those numbers are, and then they understand what the only thing that you're gonna have a problem with is that if she already knows her doubles, if she already knows how to add, then it's a little bit difficult to get her to use the abacus. It might be difficult. It just depends on her attitude. So I do have 2 preschoolers in my class right now, and they're understanding the abacus, and it's taken them, I mean, I see them once a week, and the parents do the homework. It's taken them about, I don't know, about a month to finally really understand what they're doing on the abacus. Why she does not. Why do most schools not teach people how to use the abacus? I don't think there's any school that teaches the abacus. I don't think there's any school. If there is, that'd be great. But I don't know. Like, I don't know if there's anybody that does the abacus. How do you multiply? We do distributed property. Hello, Koa. We can multiply if we can go up to 40,000. Thank you so much for checking in. Hello, Jeremiah. Good morning. Good evening. Good evening, Jeremiah. If you guys can get me to 40,000, we'll do some multiplication. How's that sound? We could do this one. Yeah? Good evening, Jeremiah. Good evening. So we have our next number, right? We have 1 and then 5. Thank you so much. And then we want to do 13. We do 1 and then 3. I'm blind and I learned this as a kid. Oh, hey. So do you have the Kramer abacus? I'm blind and I learned as a kid. My Braille teacher. That's fantastic. I'm surprised. I wonder how you're able to watch this now if you're blind. Math makes my head hurt. Yeah. You have to stop doom scrolling. Because your brain is being more active now, right? It's like exercising. Oh, and then we want to add 20. So we add the 2 and the 0. That's what it is. So my final answer is, what's my final answer? Oh, it's right there. It's 48. I need the thing. Oh, mostly med math is a relief. My nursing. Oh yeah. Yeah, there's a nursing. There's a few nursing TikTokers. Do you see them? There's a few nursing TikTokers that teaches nursing and stuff. I don't know their subjects. I don't know the subjects very well. I just know that they're there. Have you seen them, Jordan? Nursing TikTokers or nurse TikTokers. They teach about the exams and stuff. Yes, I've been read through. Oh, okay. Yeah, I don't know their logistics on stuff. I just know what I'm doing. I know that I also know that there's a chemistry teacher as well. Okay, we're gonna do this one. So we have 25 on the abacus. Oh, we're almost at 40. Okay, get ready. I gotta get ready for multiplication now. Multiplication is actually just distributive property. Thank you. I totally appreciate recommendations. Oh yeah, no, not a problem. I don't know their content. I just know that they're out there. Cause I try to follow a few people. I know there's a chemistry one. There's an algebra one if you're interested. I know a calculus person. So there's a bunch of out there. I don't know too many people that teach abacus like I do. Because the way I teach abacus is trying to make it more mainstream. And so like a lot of the terminologies that I say is very much mainstream. So we're going to finish this and then we'll go into multiplication. Thank you everybody for the 40K. So we have 25 plus 54 plus 50 plus 4 and then add the 20. Add the 2. Chem is awful. But all I need now is med math, which is basically, dimensional analysis. Oh, that's interesting. That's really interesting. All right. Multiplication. Thank you everybody for the likes. All right. So, multiplication is distributive property. Yeah, which I actually enjoy. We'll do this one. 32 times that by 9. Easy. Why? Because one thing you need to know your multiplication fact. So in Abacus world, you need to know your multiplication fact. And distributive property means we take this number and then we take this number, right? So we're going to do 9 times 3. What is 9 times 3? Oh, sorry. I got to count my digits. 1, 2, 3. So I'm going to be in the hundreds when I do my abacus. my answer is going to be on the hundreds. It will always be that way no matter what. So, what is 9 times 3? 9 times 3. Thank you, Hunter. 27. So, thank you, Jordan. I add the 2, right? My 20, and I add my 7. Notice I don't need to say 9 times 30. Thank you, Jackie, not Chan. Haha, that's funny. So notice I don't need to say 30, right? The reason why is because my abacus tracks my numbers. I don't need to do this one, and there's no multiplication fact that does 30. The only multiplication fact that I have is goes 9 times 3. So we need to remember our multiplication fact. 9 times 3 is equal to 27. So I just put 20 and I put 7. But notice it actually says 270. 270. So my next one that I'm going to do is I'm going to do 9 times 2. What is 9 times 2? Thank you, Jordan. 9 times 2 is 18. Thank you, Hunter. Plus the 1 plus the 8 plus the 1 plus the 8. So what is my final answer? Thank you, Koa. What is my final answer? I don't know if you can read that. There we go. What is my final answer? Thank you. It is 288. That's my final answer. 288. And that's all it is we're doing on the abacus. We do distributive property. So 2, 1, 1, that's 2. Touching the horizontal bar, we have the top is a value of 5, and then the 3, 1, 1, 1. That's the value of 1, right? 5 plus 3 is equal to 8. 5 plus 3 is equal to 8. Thank you, Hunter. So we have our next one. We'll do this one. 75 times that by 3, right? And I think that would be my last one. Again, what we're going to do is we need to figure out our concept, right? We need to figure out where we're going to put our answer. 1, 2, 3. 1, 2, 3. So I'm going to put my first number here. We do 3 times 7. 3 times 7. What is 3 times 7? I did it in my head. Oh, good. Man, I'm too new. I can't believe I learned it. Haha. Hello, hey, Star Child. Welcome. Thank you. Thank you. It is 21. So I had my 2, I had my 1. And then I have my next number. 5 times 3. What is 5 times 3? Thank you, Jackie. Thank you, Star Child. Thank you, Angel. Thank you, Chris. Thank you, Angel. Yes, 15, right? So guess what? I add the 1 and I add the 5. So what is my final answer? Thank you, Star Child. Thank you, Hunter. Thank you, Jackie. Thank you, Chris. Thank you, Angel. Right? So what is my answer? 255. 225. Easy, right? So what are we doing? We're learning how to read the abacus. We're doing distributive property on the abacus. We can do one more? We'll do one more. We'll do this one. 56 times that by 8. Yep. So we count it again. We do 1, 2, 3, right? 1, 2, 3. Why do we count it? We count it because we want to know where we're going to put our product. That's what we're going to do. Thank you, Hunter. But the first thing we're going to do is we're going to understand 8 times 5. 8 times 5 is what? What is 8 times 5? Thank you, Jackie. 8 times 5 is 4 and a 0. And then we do 8 times 6. What is 8 times 6? 8 times 6 is 48. Thank you, Jay. Yes, 48. Add the 4, add the 8. So final answer is, thank you, Jackie. Yes, thank you. Thank you, Hunter. Thank you, Jay. Thank you, Koa. Right? Thank you, Koa. Yes, it is 448. That's it. So what we just did is we did distributive property. That's it. We could do more, but I'm going to turn it. Excuse me. Yeah, thank you. Thank you, Koa. No, you're welcome. Thank you. Thank you for the question. I do appreciate it. It was fun. Oh, thank you, Jay. It's interesting. I'll tell you that. But the biggest thing is know your formulas, because once you know your formulas, then you can add bigger numbers. Can you do a real simple, quick, for me, 5 plus 5? Well, the one thing about 5 plus 5, 5 times 5, is you need to know your formulas. So the big thing about understanding your 5 times 5 is you need to know your formulas, right? So we have 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25. Have I seen the box method for multiplying? Yes. But I had somewhere, thank you. I've always liked math, but teachers made. Oh, sorry, challenge. Yeah, it's too bad that the teachers made. Well, the teachers probably didn't understand math too either. Have I seen them? I did see the box method, and it is kind of what Abacus is doing. I think the difference in the box method is that you're putting it on paper. And if I do it on a piece of paper, and that's what the difference is, right? So if I had, what number? Here. If I had, but I think the box method is a little bit. I don't know. I actually don't know how to do the box method, but this is how I see it. So if I had the question, 52 times 9, right? So we do this, 45, but then you do the 0. And then you do this, it would be 18. Which is exactly what we do on the abacus, because it's 45 on the abacus. But we don't need to worry about the 0. But you have to worry about the 0 because you're writing it. So that's the difference. And then we do 18, add the 1, add the 8. So the difference is what? Well, you're writing it out on a piece of paper, or you do it on the abacus. Do you use the abacus to teach basic, or do you memorize the facts? I teach the kids on repeated addition. That's what I do, and then I tell them to practice it, and until they like it, until it becomes memorized. So I just tell them to keep doing repeated addition, and they can do it, cause once you see it enough times, you'll start to gravitate between the different numbers. Yeah, my math teacher. Jackie, why would you think that you know this? This is just different. Just because you have a math brain doesn't mean that you should know how to use the abacus. Nobody knows how to use the abacus when they're born. Did that make sense, Star Child? So, well, I would just have them do repeated addition until they understand it. And I think that's what it is just, I think we need to get them to practice how to do repeated addition or different ways of multiplication before we get them to start memorizing the numbers, because it's just one of those things, like we do want them to understand what it means when it says 4 times 5 or 5 times 4. That's the thing. Yeah. So, but yeah, if you're talking about formulas are good. And then it would also solidify it. I want it to click. Oh, I see. So you know how to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So you want it to click. It would click when we start talking about adding on the abacus. So like this one, 4 plus 4. 4, and we want to add another 4, but there's not enough beads to add a 4. So what do? We have to plus the 5 minus the 1. Well, why would we do that? Well, in Abacus world, we actually take our numbers like that. We want to add another 4. We're adding another 4 like this. But instead of counting up, what we're going to do is we're going to make this, and we're going to round this up to a 5. We got to round it up to a 5. So what is it? That's 4 plus 1 will equal to 5. Well, where's the 1 going to come from? The 1 has to come from the first number. So you take away 1 from here, and you add it to the bottom number, and that becomes 5. Oops. That becomes 5. So what do? We take away 1 from the first number, and you add the 5. So my final answer is 8. Okay. But thank you everybody for joining. I do appreciate it. I am going to head out. I'm really tired. Yeah. Thank you everybody. Oh my god. I think I do this in my fingers, and yeah. Yeah, see, that's what I'm saying, Jackie. Because if you can do it in your brain, then this is how it is. This is what we do. So in Abacus world, we round up to 10, and we round up to 5. So you're in good hands. Yeah. So it's gonna click. It's just working it differently on the Abacus. That's all. Not a problem, Jackie. Not a problem. I hope to see you in my next live, and hopefully we can talk more about this later. Thank you, Jackie. Thank you. I can't wait. Yes, see you all in my next live. Thank you, everybody. Thank you.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
Thank you, everybody, for joining. Thank you, everybody, for joining. And I'll see you all in my next live.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Bye, everybody. Bye, Star Child.